Undoubtedly, machine learning is the most in-demand technology in today's market. Its applications range from self-driving cars to predicting deadly diseases such as ALS. The high demand for machine learning skills is the motivation behind today's live session. Hi everyone, this is Edureka from Edureka, and I welcome you to this live session on Introduction to Machine Learning. Now, before I get started with the session, please give me a confirmation if I'm audible to all of you. All right, so I see a couple of yeses. Okay. All right, then let's get started with the session. So let me discuss the agenda with you first. Now we're going to begin the session by understanding the need for machine learning and why it is important. After that, we'll look at what exactly machine learning is, and then we'll discuss a couple of machine learning definitions. Once we're done with that, we'll look at the machine learning process and how you can solve a problem by using the machine learning process. Next, we'll discuss the types of machine learning, which include supervised, unsupervised, and reinforcement learning. Once we're done with that, we'll discuss the different types of problems that can be solved by using machine learning. Finally, we'll end this session by looking at a demo where we'll see how you can perform weather forecasting by using machine learning. All right, so guys, let's get started with our first topic. So what is the importance or what is the need for machine learning? Now, ever since the technical revolution, we've been generating an immeasurable amount of data. As per research, we're generating around 2.5 quintillion bytes of data every single day. And it is estimated that by 2020, 1.7 MB of data will be created every second for every person on Earth. Now, that is a lot of data. Right now, this data comes from sources such as the cloud, IoT devices, social media, and all of that. Since all of us are very interested in the internet right now, we're generating a lot of data. All right, you have no idea how much data we generate through social media. All the chatting that we do and all the images that we post on Instagram, the videos that we watch, all of this generates a lot of data. Now, how does machine learning fit into all of this? Since we're producing this much data, we need to find a method that can analyze, process, and interpret this much data. All right, and we need to find a method that can make sense out of data. And that method is machine learning. Now, there are a lot of top-tier companies and data-driven companies such as Netflix and Amazon, which build machine learning models by using tons of data in order to identify any profitable opportunities. And if they want to avoid any unwanted risks, they make use of machine learning. All right. So through machine learning, you can predict risks, you can predict profits, you can identify opportunities which will help you grow your business. So now I'll show you a couple of examples wherein machine learning is used. All right. So I'm sure all of you have binge watched on Netflix. Now, the most important thing about Netflix is its recommendation engine. All right. Most of Netflix's revenue comes from its recommendation engine. So the recommendation engine basically studies the movie viewing patterns of its users and then recommends relevant movies to them. All right. It recommends movies depending on users' interests, depending on the type of movies the user watches and all of that. All right. So that is how Netflix uses machine learning. Next, we have Facebook's auto tagging feature. Now, the logic behind Facebook's auto tagging feature is machine learning and neural networks. I'm not sure how many of you know this, but Facebook makes use of DeepMind face verification system, which is based on machine learning, natural language processing, and neural networks. So DeepMind basically studies the facial features in an image and it tags your friends and family. Another such example is Amazon's Alexa. Now, Alexa is basically an advanced level virtual assistant that is based on natural language processing and machine learning. Now, it can do more than just play music for you. All right, it can book your Uber, it can connect with other IoT devices at your house, it can track your health, it can order food online and all of that. Okay, so data and machine learning are basically the main factors behind Alexa's power. Another such example is the Google spam filter. So guys, Gmail basically makes use of machine learning to filter out spam messages. If any of you just open your Gmail inbox, you'll see that there are separate sections. There's one for primary, there's social, there's spam, and there's your general mail. Now, basically, Gmail makes use of machine learning algorithms and natural language processing to analyze emails in real time and then classify them as either spam or non-spam. Now, this is another famous application of machine learning. So, to sum this up, let's look at a few reasons why machine learning is so important. So, the first reason is obviously increase in data generation. So, because of excessive production of data, we need a method that can be used to structure, analyze, and draw useful insights from data. This is where machine learning comes in. It uses data to solve problems and find solutions to the most complex tasks faced by organizations. Another important reason is that it improves decision making. So by making use of various algorithms, machine learning can be used to make better business decisions. For example, machine learning is used to forecast sales. It is used to predict any downfalls in the stock market. It is used to identify risks, anomalies, and so on. Now, the next reason is it uncovers patterns and trends in data. Finding hidden patterns and extracting key insights from data is the most essential part of machine learning. So, by building predictive models and using statistical techniques, machine learning allows you to dig beneath the surface and explore the data at a minute scale. Now, understanding data and extracting patterns manually will take a lot of days. Now, if you do this through machine learning algorithms, you can perform such computations in less than a second. Another reason is that it solves complex problems. So, from detecting genes that are linked to deadly ALS diseases to building self-driving cars and building face detection systems, machine learning can be used to solve the most complex problems. So, guys, now that you know why machine learning is so important, let's look at what exactly machine learning is. The term machine learning was first coined by Arthur Samuel in the year 1959. Now, looking back, that year was probably the most significant in terms of technological advancements. Guys, if you browse through the net about what is machine learning, you'll get at least 100 different definitions. Now, the first and very formal definition was given by Tom M. Mitchell. Now, the definition says that a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at tasks in T as measured by P improves with experience E. Alright. Now, I know this is a little confusing, so let's break it down into simple words. Now, in simple terms, machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically and improve from experience without being explicitly programmed to do so. In the sense, it is the practice of getting machines to solve problems by gaining the ability to think. But wait, now how can a machine think or make decisions? Well, if you feed a machine a good amount of data, it will learn how to interpret, process, and analyze this data by using machine learning algorithms. Okay. Now, guys, look at this figure on top. Now, this figure basically shows how a machine learning algorithm or how the machine learning process really works. So the machine learning process begins by feeding the machine lots and lots of data. Okay, by using this data, the machine is trained to detect hidden insights and trends. Now, these insights are then used to build a machine learning model by using an algorithm in order to solve a problem. Okay. So basically, you're going to feed a lot of data to the machine. The machine is going to get trained by using this data. It's going to use this data and it's going to draw useful insights and patterns from it. And then it's going to build a model by using machine learning algorithms. Now, this model will help you predict the outcome or help you solve any complex problem or any business problem. So that's a simple explanation of how machine learning works. Now let's move on and look at some of the most commonly used machine learning terms. So first of all, we have algorithm. Now this is quite self-explanatory. Basically, algorithm is a set of rules or statistical techniques which are used to learn patterns from data. Now, an algorithm is the logic behind a machine learning model. All right. An example of a machine learning algorithm is linear regression. I'm not sure how many of you have heard of linear regression. It's the most simple and basic machine learning algorithm. All right. Next, we have model. Now, model is the main component of machine learning. All right. So, model will basically map the input to your output by using the machine learning algorithm and by using the data that you're feeding the machine. So basically, the model is a representation of the entire machine learning process. So the model is basically fed input, which is a lot of data, and then it will output a particular result or a particular outcome by using machine learning algorithms. Next, we have something known as predictor variable. Now, predictor variable is a feature of the data that can be used to predict the output. So for example, let's say that you're trying to predict the weight of a person depending on the person's height and their age. All right. So over here, the predictor variables are your height and your age, because you're using height and age of a person to predict the person's weight. All right. So the height and the age are the predictor variables. Now, weight, on the other hand, is the response or the target variable. So response variable is a feature or the output variable that needs to be predicted by using the predictor variables. All right. After that, we have something known as training data. So guys, the data that is fed to a machine learning model is always split into two parts. First, we have the training data and then we have the testing data. Now, training data is basically used to build the machine learning model. So usually training data is much larger than the testing data, because obviously if you're trying to train the machine, then you're going to feed it a lot more data. Testing data is just used to validate and evaluate the efficiency of the model. All right. So that was training data and testing data. So guys, these were a few terms that I thought you should know before we move any further. Okay, now let's move on and discuss the machine learning process. Now this is going to get very interesting because I'm going to give you an example and make you understand how the machine learning process works. So first of all, let's define the different stages or the different steps involved in the machine learning process. So a machine learning process always begins with defining the objective or defining the problem that you're trying to solve. Next stage is data gathering or data collection. Now the data that you need to solve this problem is collected at this stage. This is followed by data preparation or data processing. After that, you have data exploration and analysis. And the next stage is building a machine learning model. This is followed by model evaluation. And finally, you have prediction or your output. Now let's try to understand this entire process with an example. So our problem statement here is to predict the possibility of rain by studying the weather conditions. So let's say that you're given a problem statement and you're asked to use a machine learning process to solve this problem statement. So let's get started. All right. So the first step is to define the objective of the problem statement. Our objective here is to predict the possibility of rain by studying the weather conditions. Now, in the first stage of a machine learning process, you must understand what exactly needs to be predicted. Now, in our case, the objective is to predict the possibility of rain by studying weather conditions, right? So at this stage, it is also essential to take mental notes on what kind of data can be used to solve this problem, or the type of approach that you can follow to get to the solution, all right? A few questions that are worth asking during this stage is, what are we trying to predict? What are the target features or what are the predictor variables? What kind of input data do we need? And what kind of problem are we facing? Is it a binary classification problem or is it a clustering problem? Now, don't worry if you don't know what classification and clustering is. I'll be explaining this in the upcoming slides. So guys, this was the first step of a machine learning process, which is define the objective of the problem. All right, now let's move on and look at step number 2. So step number 2 is basically data collection or data gathering. Now at this stage, you must be asking questions such as what kind of data is needed to solve the problem? Is the data available? And if it is available, how can I get the data? Okay, so once you know the type of data that is required, you must understand how you can derive this data. Data collection can be done manually or by web scraping. But if you're a beginner and you're just looking to learn machine learning, you don't have to worry about getting the data. Okay, there are thousands of data resources on the web. You can just go ahead and download the data sets from websites such as Kaggle. Okay, now coming back to the problem at hand, the data needed for weather forecasting includes measures such as humidity level, temperature, pressure, locality, whether or not you live in a hill station, and so on. So guys, such data must be collected and stored for analysis. Now the next stage in machine learning is preparing your data. The data you collected is almost never in the right format. So basically, you'll encounter a lot of inconsistencies in the data set. Okay, this includes missing values, redundant variables, duplicate values, and so on. Removing such values is very important because they might lead to wrongful computations and predictions. So that's why at this stage, you must scan the entire data set for any inconsistencies, and you have to fix them at this stage. Now, the next step is exploratory data analysis. Now, data analysis is all about diving deep into data and finding all the hidden data mysteries. Okay, this is where you become a detective. So, EDA or exploratory data analysis is like the brainstorming of machine learning. Data exploration involves understanding the patterns and the trends in your data. So, at this stage, all the useful insights are drawn and all the correlations between the variables are understood. So you might ask, what sort of correlations are you talking about? For example, in the case of predicting rainfall, we know that there is a strong possibility of rain if the temperature has fallen low. Okay, so such correlations have to be understood and mapped at this stage. Now, this stage is followed by stage number 5, which is building a machine learning model. So all the insights and the patterns that you derive during data exploration are used to build the machine learning model. So this stage always begins by splitting the data set into two parts, training data and the testing data. So earlier in this session, I already told you what training and testing data is. Now the training data will be used to build and analyze the model, and the logic of the model will be based on the machine learning algorithm that is being implemented. Okay. Now in the case of predicting rainfall, since the output will be in the form of true or false, we can use a classification algorithm like logistic regression. Now, choosing the right algorithm depends on the type of problem you're trying to solve, the data set you have, and the level of complexity of the problem. So in the upcoming sections, we'll be discussing different types of problems that can be solved by using machine learning. So don't worry if you don't know what classification algorithm is and what logistic regression is. Okay. So all you need to know is at this stage, you'll be building a machine learning model by using machine learning algorithm and by using the training data set. The next step in a machine learning process is model evaluation and optimization. So after building a model by using the training data set, it is finally time to put the model to a test. Okay. So the testing data set is used to check the efficiency of the model and how accurately it can predict the outcome. So once you calculate the accuracy, any improvements in the model have to be implemented in this stage. Okay. So methods like parameter tuning and cross-validation can be used to improve the performance of the model. This is followed by the last stage, which is predictions. So once the model is evaluated and improved, it is finally used to make predictions. The final output can be a categorical variable or it can be a continuous quantity. In our case, for predicting the occurrence of rainfall, the output will be a categorical variable. In the sense, our output will be in the form of true or false, yes or no. Yes basically represents that it's going to rain, and no will represent that no, it won't rain. Okay, as simple as that. So guys, that was the entire machine learning process. Now let's look at the different ways in which machines can learn. Okay. So there are three well-defined types of machine learning, which is supervised, unsupervised, and reinforcement learning. Now, supervised learning is a technique in which we teach or train the machine using data which is well labeled. To understand supervised learning, let's consider a small analogy. Okay. So as kids, we all needed guidance to solve math problems. Our teachers helped us understand what addition is and how it is done. Similarly, you can think of supervised learning as a type of machine learning that involves a guide. Okay, the label data set is a teacher that will train you to understand patterns in the data. The label data set is nothing but the training data set. So to make you understand this in a better way, look at the figure in this slide. Okay, so in this image, we are feeding the machines images of Tom and Jerry, and the goal is for the machine to identify and classify the images into two groups, which is Tom and the other containing images of Jerry. Okay, the training data set that is fed to the model is labeled, as in we're telling the machine that this is how Tom looks and this is how Jerry looks. Now, by doing so, you're training the machine by using labeled data. So basically, in supervised learning, there is a well-defined training phase done with the help of labeled data. Now, the processes in between are the same as we discussed earlier. So you're going to start by feeding labeled data to your machine. Okay, then you're going to perform data cleaning, wherein you'll remove all the missing values, all the redundant values, and then you'll perform exploratory data analysis in order to draw useful insights or in order to understand any patterns or trends. Once you're done with that, you'll move on and build a machine learning model by using a machine learning algorithm. Finally, you'll evaluate the model that you built by using the testing data set, and then you'll predict the class of the image. You'll classify it into either class Jerry or class Tom. So here, guys, the output is also labeled. All right. The most important thing about supervised learning is that you're going to feed the machine labeled data set. Now let's look at unsupervised learning. So unsupervised learning involves training by using unlabeled data and allowing the model to act on that information without any guidance. Think of unsupervised learning as a smart kid that learns without any guidance. Okay, so in this type of machine learning, the model is not fed with labeled data, as in the model has no clue that this image is Tom and this image is Jerry. It figures out patterns and differences between Tom and Jerry on its own by taking in tons of data. For example, it identifies prominent features of Tom, such as pointy ears, it is bigger in size, and so on. Okay, so after it understands that this image has pointy ears and bigger size, it will classify that image as type 1. Okay, let's say that it will classify that image as the first type. Similarly, it finds features in Jerry such as it's smaller in size when compared to Tom, and it understands that this image is different from the first type of image. Okay, that's how it classifies the images into two different classes without knowing who is Tom and who is Jerry. So basically here you're not teaching the machine anything, you're not giving it a labeled data set. Instead, you're just giving it random images and you're telling, listen, classify these set of images into two classes. All right. The rest of the process is similar. The only difference is that you're feeding unlabeled data over here, and the machine has to understand patterns and has to find trends on its own without any guidance. Okay. Now, guys, the output of an unsupervised learning model is usually a cluster. Okay, since the machine has no idea about the input data, it just clusters similar items into one group. All right, so this was unsupervised learning. Now let's look at reinforcement learning. So reinforcement learning is a little bit different when compared to unsupervised and supervised learning. It is a part of machine learning wherein an agent is put in an environment and he learns to behave in this environment by performing certain actions and observing the rewards which it gets from those actions. Okay, to understand how reinforcement learning works, imagine that you were dropped off at an isolated island. Okay, what would you do? Now, panic, obviously, all of us would panic initially, but as you spend more time in the island, you will learn how to live on the island. Okay, you will explore the environment, you'll understand the climate conditions, the type of food that grows there, the dangers of the island, and so on. This is exactly how reinforcement learning works. It involves an agent, which is basically you stuck on the island, and this agent is put in an unknown environment where he must learn by observing and performing actions that result in rewards. All right. So when it comes to reinforcement learning, the machine learning model or the machine learning algorithm is basically the agent. Okay. So basically the reinforcement learning agent will collect data on its own. It will perform everything on its own from data collection to model evaluation. Okay. It has to explore the entire environment, collect relevant data, perform analysis, and try to figure out everything by itself. Okay. That's how reinforcement learning works. Now let's move on and look at the differences between supervised, unsupervised, and reinforcement learning. So first of all, like I mentioned, supervised learning makes use of labeled data. Unsupervised learning trains a machine by using unlabeled data, whereas in reinforcement learning, there is an agent which interacts with the environment and produces some actions and discovers errors and rewards. Now, the types of problems that can be solved by using supervised learning include regression and classification. All right, I'll be explaining regression and classification in the further slides. Unsupervised learning basically includes clustering, and reinforcement learning can be used to solve reward-based problems. Now, the type of data set that is involved in supervised learning is labeled. In unsupervised learning, it is unlabeled data, and in reinforcement learning, there is no predefined data set. Now, when it comes to training, in supervised learning, we have external supervision, which is basically the label data set. In unsupervised and reinforcement learning, there is no supervision. Now, the approach of supervised learning is to map the labeled input to the known output. All right, so here you know both the input and the output. All you have to do is you have to map the input to the output. Coming to unsupervised learning, you have to understand the patterns in your data and discover the output on your own. Reinforcement learning, on the other hand, follows the trial and error method. Now, since the agent has no idea about the environment, obviously he has to go around trying new things and then learn from his experience. Now, popular algorithms under supervised learning are linear regression, logistic regression, support vector machines, and so on. Under unsupervised learning, we have the most famous k-means clustering algorithm. Under reinforcement learning, we have the Q-learning algorithm. All right. So guys, I hope I cleared the confusion between supervised, unsupervised, and reinforcement learning. Now let's move on and discuss the different types of problems that are solved by using machine learning. So there are three main types of problems that fall under machine learning. First of all, we have regression. Now, in this type of problem, the output is a continuous quantity. So for example, if you want to predict the speed of the car when the distance is given, it is a regression problem. Okay, regression problems can be solved by using supervised learning algorithms like linear regression. Classification, on the other hand, the output is always a categorical value. Okay, so classifying emails into two classes, that is spam and non-spam, is a classification problem that can be solved by using supervised learning classification algorithms like support vector machines, naive Bayes, logistic regression, and k-nearest neighbor. Another type of problem is the clustering problem. Now, this type of problem involves assigning the input into two or more clusters based on feature similarity. For example, if you want to cluster viewers based on their interests or based on their age and geography, you can do that using clustering. Okay, and clustering problems are solved by using unsupervised learning algorithms like k-means. So guys, these are the three different problems that are solved by using machine learning. So to make you understand the type of problems in a better way, I've collected three problem statements and let's try to understand how you can solve these problems. Okay. So in this problem statement, you have to study the house sales data set and build a machine learning model that predicts the house pricing index. Now, when you read house pricing index, you must understand that house pricing index is a continuous quantity, right? It's not a categorical quantity or it's not a categorical variable. So as soon as you understand that you have to predict a continuous quantity, you must know that this is a regression problem. All right. So this is the data set and you can make use of linear regression algorithm in order to predict the house pricing index. Now let's look at our next question. Here the statement is to study a bank credit data set and make a decision about whether to approve the loan of an applicant based on his profile. Now read the question properly. What do you have to predict? You have to predict whether you can approve the loan of an applicant or not. Okay, so here there are going to be two outputs. Approve loan and reject loan means that this is a categorical output. So that's how we get to know that this is a classification problem. Right? So for this problem, you can make use of the KNN algorithm or the K nearest neighbor algorithm, which is basically a classification algorithm. Let's look at another problem statement. Now here you have to cluster a set of movies as either good or average based on their social media outreach. Now the clue itself is in the question. This is obviously a clustering problem because you have to group a set of movies. Now if the word cluster wasn't there, you still have to understand that this is a clustering problem because I've said a set of movies as either good or average. Okay, so you're basically grouping movies, right? So this is a clustering problem. Right, for this you can make use of the k-means algorithm, which is a clustering algorithm. Now moving on to the last part of our session, which is our practical demo. Now before we start executing the demo, let's look at the problem that we're going to try and solve. So the problem statement is we're going to study the Seattle weather forecast data set and we're going to build a machine learning model that can predict the possibility of rain. All right, so here's a picture of the data set. Now the data set contains 5 variables. Date basically represents the date of the observation. PRCP stands for the precipitation, which is useful in measuring the possibility of rain. Tmax stands for the maximum temperature for that day in Fahrenheit. Tmin stands for the minimum temperature of that day. And the final variable is the rain variable, which has two values, either true or false. Now, this is exactly where you understand that this is a classification problem. Since you have to predict whether or not it's going to rain, it means that your output is going to have two values, either yes or no, or true or false. All right. So guys, date, precipitation, maximum temperature and minimum temperature are your predictor variables, and your target or your output variable is rain. So you're going to use these four predictor variables in order to predict whether it is going to rain or not. All right. So I hope all of you are clear with the problem statement. For this problem statement, we'll be using the logistic regression algorithm, which is a classification algorithm. It'll basically classify an input into two or more classes. Now let's move on to the coding part. All right, this is where it gets interesting. Now, a short disclaimer that I'll be using the R language to show you how machine learning works. Now guys, R is a statistical programming language which is mainly used for data science and machine learning. If you want to learn more about R, then I'm going to leave a link in the description box. You can go through that video and you can try and understand how R programming happens. Now, for this demo, I'll be explaining each and every line. So don't worry if you don't know much about R, but I am assuming that you have a little bit knowledge about the language. Okay. So to save up time, I've already typed out the code. Don't worry, I'll be explaining the entire code to you. So if you have any doubts while I'm running the demo, please ask questions in the live chat. All right, I'll try to answer all of the questions. So remember, the logic over here is to build a logistic regression model in order to predict whether or not it will rain on a particular day based on the weather conditions. All right. So first step is always importing and installing the packages needed to run the demo. Okay, so these are all the libraries. I've already loaded the libraries. All you have to do is select the part of the code and run it. Okay, now these libraries are basically provided by R. Okay, we're using the forecast library, tidyverse, we're using caret, and we're using the ROCR. Now the next line over here is importing the data set. So what I'm doing here is my data set is stored in this path. All right. All I'm doing is I'm passing this path in a function known as read.csv. Now read.csv is basically used to read comma separated versions or comma separated files. All right. So my data set basically is of type CSV. That's why I'm using the read.csv function. And I'm storing the entire data in a variable called data.df. Okay. So let me run this entire line. All right. So I've loaded my data set in my R console. Next, what I'm going to do is I'm going to display the first few observations in my data set. To do that, there is a function known as head in R. So all you have to do is you have to use the head function and run data.df as a parameter. So let's run this line. All right. So if you look at the output over here, let me just zoom in a little bit. All right. So guys, these are the first 6 observations in my data set. So like you can see, we have the date variable, we have the precipitation variable, maximum temperature, minimum temperature, and finally the rain variable. Okay, this rain is our output variable, and these are basically the observations. All right. So similarly, you can view the last few observations by using the tail function. All right. Now all that is not needed right now. So for now, let's study the structure of the data set. To do that, there is a function known as str in R. Okay, all you have to do is run the str function with the data set. So let me run this. Now, if you notice over here, you can see that the data type for date and the data type for rain is not correctly formatted. Okay, for these things, we have integers and numbers, but these are not correctly formatted data types. So what we're going to do is we're going to factorize these two variables. So that's where data cleaning comes in. Okay, so here we're going to format date and rain variable. So for the date variable, we're going to set the data type as date, and for the rain variable, we'll set the data type as factor. All right, it has to be a factor. So let's run this as well. Now, if you look at the structure of the data set, here you can see that this has changed to date and this has changed to factor. right? That's exactly what we need. Now, the next step is data cleaning. So if you all remember in the machine learning process, I mentioned that we have to get rid of any missing values or any null values. Okay, that's exactly what we're doing here. First, we're checking if there are any null values in our date variable. Okay, this is how you do that in R. So let me run this code. Now this gives us an output of integer 0, meaning that there's no null value in the date variable. Similarly, we'll do this for the precipitation variable. All right. So basically in these columns, we have missing values. All right. We'll be dealing with this shortly. First, let's check if the tmax variable also has a null value. All right. This is 0. And even for the tmin variable, we don't have any null value. Let's check the rain variable, guys. That's very important because it's our predictor variable. All right, here also we have 3 missing values. So what we're going to do is we're going to remove the rows with the missing rain values. All right, so let's select this line. This line will basically remove the columns that have the missing values. All right, so run this, and now we won't have any missing values. So to check if our null values are removed, I'm just going to run this line. All right, okay, so it returns 0, meaning that we don't have any more null values. Now the next step is data splicing. So guys, data splicing is just a fancy term for splitting your data set into your training data set and your testing data set. Okay, it's basically data splitting. Now to do that, we are going to use the carrot package. All right. If you want to learn more about these things, you can just open up the R documentation and they'll tell you what exactly carrot package is. Okay, now carrot is basically a classification and regression package. But if you want to learn more about it, you can go ahead and check out the R documentation. All right. So I'm getting an error. It says that it could not find function create data partition. Now this happens because sometimes your libraries don't get loaded. So what I'm going to do is I'm going to go back to the beginning of the code. I'll try and load my library again. All right, it's loading my carrot package now. Okay, so this is done. Now let's try running the line of code. Where was I? All right, here. So now select the entire line and let's run. All right. So this means that my carrot package is loaded successfully. Now what I'm doing here is I am setting the index to 0.7, meaning that I am splitting the data set in a ratio of 7:3. So 70% of my data set will be the training data set and 30% of my data set will be in the testing. All right. So here is where I create a separate variable for my training data set, which is train.df. All right. And here I'm creating a separate variable for my testing data set, which is test.df. Okay, so let me run this. All right. So if you want to view your training and your testing data set, you can use the head function again. It gives you the first 6 observations. Similarly, if you want to view the summary of the testing data set, you can use a summary function. All right, this will just show you the minimum, median, and the mean of each of the variables. All right, now the next step is data exploration. Now first of all, in data exploration, what I'm doing is I'm setting the rain variable as numeric. Okay, now the reason I'm doing this is because I'm going to compute the correlation between the rain variable and the tmax and tmin variable. Okay, I'm doing this because I want to understand how related the rain variable and the tmax variable are. All right, I want to understand the relation between the two. I want to know how important tmax variable is in predicting whether or not it will rain. So basically, to find the correlation between two variables, you're going to make use of a function known as correlation test. Okay, cor.test. Here you'll pass the two variables that you want to find the correlation between. So one important thing is you have to make sure that both of these variables are of type numeric. All right, that's why in this line, I'm converting the rain variable into numeric variable because it was set to a factor initially, right? So let's run this. And now let's run the correlation test. All right. Now, the most important thing to look at in this test is the p-value. All right. Now, this p-value has to always be below 0.05. Now, guys, I know to most of you, this might seem a little confusing because you might not know what p-value is. P-value is basically the probability value. It is used to test how significant a particular variable is in building that model. Okay. So it is said that if the p-value is below 0.05, that means that Tmax is a very important variable in predicting the rain. Alright. So here if you see that our p-value is much less than 2.2 to the power of minus 16. Alright. So that is very, very small, which means that our Tmax variable is very important in predicting the rain. Alright. Similarly, we're going to do this for the Tmin variable. Here also the p-value is really small, all right, and also this denotes the correlation between the variables. All right, now here if you see that the correlation is minus 0.38. So guys, the correlation value will range between -1 and +1. So if your correlation value is negative, it means that the relationship between the two variables is indirectly proportional to each other. Meaning that if you increase the temperature, then there is a lesser possibility for it to rain. Okay. And similarly, if you decrease the temperature, then there is a high possibility that it's going to rain. All right. That's what the negative sign denotes. It means that there is a negative or an inverse relationship between the two variables. So now that we know both of these variables are significant, let's go ahead and build the model. Okay, so before doing that, I'm going to factorize the rain variable again, all right, because this has to be a categorical variable. Now, finally, we'll build the model by using the GLM function. GLM stands for Generalized Linear Models, all right. So this is basically where logistic regression comes into the picture. What we're doing is we're passing the rain variable, which is our output variable, and we're passing the predictor variables. Then we're passing the data set that we are using to build the model, which is train.df. And finally, we're mentioning that the family is binomial. Now, this family equal to binomial denotes that we're using a logistic regression model. All right. To understand logistic regression, it'll take a lot of time. So what I'm going to do is I'll leave a link in the description. If you want to understand logistic regression, you can go through that link. All right. So let's run this line of code. Now to look at the summary of the model, we'll run this code. All right. So again, if you look at the coefficients over here, we're using Tmax and Tmin, right? Here again, the value of P is really, really small, meaning that these two variables are very significant in building the model. All right. So now we've created the model. What we have to do next is we have to evaluate the efficiency of the model. So what we're going to do is in model evaluation, first of all, we'll predict the efficiency of the model. Okay, to do that, we'll use a predict function and we'll run the testing data set over here. That's why I've given parameter as test.df. Okay, now we're going to store the values in a variable known as predicted values. Okay, so let's run this line of code. If you want to look at the first 6 observations of the predicted values, let's run this line of code. All right. Now these values are not in the proper format. So in the next couple of lines, we'll be fixing all of this. Okay. Now what we're doing is we're creating a table which contains the actual rain values in the testing data set. So guys, let me run these few lines of code and then you'll understand why exactly I'm doing this. Okay, so first we'll create a table which contains the actual rain values. All right. Here we're calculating the number of rows that are there in the testing data set. All right. I'll tell you why exactly I'm doing this. Just bear with me. After that, we'll create a data frame which contains the predicted rain values. All right. So all the values that you just predicted will be stored in this prediction variable. All right. Here, what you're passing is you're passing the number of rows. This variable basically denotes the number of rows that are there in our testing data set. Okay. So you're basically creating another table or you're creating another data frame that will store all the predicted values. Okay. So let's run this line of code as well. Next, I'm just naming the column as rain. All right. And if you want to look at the structure of our data frame, let's look at the structure. So the first thing that you're going to notice here is that our rain variable is of type integer. Okay. We do not want the rain variable as to be an integer because we want it to predict whether it's raining or not. And this way we will not understand anything. So what we're going to do is we're going to convert it into characters. Okay, next what you're going to do is you're going to set the entire rain variable as true. Okay, I'll tell you why you're doing this. Okay, first you're setting the entire thing as true. and then you're setting a threshold. So any value that is less than 0.5 will be set to false. Okay, this is basically probability. Anything that is less than 0.5, you'll be setting that value as false, and anything above 0.5 will be set to true. All right, so if your rain variable has a value of 0.3, it means that it is false. It's not going to rain. But if your rain variable has a value of 0.6 or 0.7, it means that the value is true, which means that it will rain. All right, so let's run this. And now we'll finally convert it to a factor. All right, now if you look at the structure of your prediction, you'll get two levels. All right, you'll get false and you'll get true. All right, so guys, these were our predictions. Now you can look at the final table. Now in this table, you're basically comparing your actual rain values to your predicted rain values. All right, so this false ratio shows that 3,426 data points were correctly classified as false. All right, now 933 were not classified correctly. Similarly, 2,396 variables were correctly classified as true. All right, you can see true, true. So there is 2,337 samples which were correctly classified as true. Okay. To sum everything up, we're just going to build a confusion matrix. But all right, here we're getting an error which says that package E107 is required. All right, so let's just install that package. Install.packages. So guys, it's very simple to install packages. Just use the command install.packages and then write the name of the package. E107. All right. Next, what you're going to do is you're going to add another command, which is library. And here you'll again mention the name of the package. All right. So let's run this line of code. All right. So now it's installing my package. So, yep, it's installed. Now we'll just load the library. All right. Now, if you run the confusion matrix, it should work. Fingers crossed. All right. So now we have our confusion matrix. So this is used to evaluate the accuracy of the model. All right. So like I said that it was correctly able to classify 3,426 values as false and 2,337 values as true. All right. The accuracy is 75%, which is 0.752, which stands for 75%. All right. So our accuracy was pretty good. 75 is a good number. All right. Given the amount of data that we had, 75% is actually a really good number. All right. Now let's just plot our final graph. Okay. This is just to show you the relationship between the predictor variable and the target variable. So this graph shows that our model has a lot of errors. All right. There are a lot of points which are way out of the line. But this is how you train a machine learning model. All right. The main idea behind this demo was to show you each and every step of a machine learning process. Now, guys, initially, even if you try building a very good model, your output will usually be like this. But machine learning works iteratively. All right. You'll have to improve the efficiency of the model by using, maybe you can use different machine learning algorithms, or you can use a more advanced data set, or you can use a more advanced technique. All right. Yeah, so that was the entire demo. Guys, if you have any doubts regarding the demo, y'all can ask the questions right away. All right, I'll answer all of the questions. And also, I hope all of you enjoyed the session. So guys, thank you so much for joining me in today's live session. I hope all of you enjoyed it.